Good afternoon and welcome to this Micrographics and Autodesk webinar. Today's webinar is going to be covering Fusion 360 and the product design extension within Fusion 360. My name is Carl van Rooyen. I'm an application engineer with Micrographics. My contact details are there on the bottom left-hand side of the slide. So today's webinar is being broadcast live on YouTube and it will also be recorded. Posted up later on YouTube as well, so you will be able to refer back to this broadcast on YouTube on our Micrographics channel, MGFXS South Africa. So just with that being said, let's have a look at our agenda for the day. We'll start off with our introduction as to why you would want to possibly look at using the product design extension. And after the introduction, we will have a look at the specific areas within the extension. So we'll have a look at being able to create plastic rules and assign plastic rules to components. We'll also look at creating presets for commands, followed on by looking at the specific plastic design tools that are unlocked with the extension. We'll move on to geometric patterns, the design advice tool, looking at organic mesh conversion as well, take scan data and convert it into T-spline data, what the volume lattice can do for you, volumetric lattice, and we'll close off with a summary and Q&A. So for our introduction, what I'd like to do is just explain a little bit about the extensions. Fusion 360 as a off-the-shelf product has a certain set of features, and for most people those features are more than what is required for them to get their jobs done on a day-to-day basis. But you'll find that certain users need extra functionality. They need to be able to do extra things, and these extensions allow them to gain extra functionality, or in some cases gain unlimited access to certain features within Fusion 360. So we typically find that those users are specialists within a specific field. So here I've got a couple of fields noted: generative design, simulation, additive manufacturing, machining, and nesting, just to name a few of the fields where there are extensions that can assist. Now, some of these will add, as I said, extra functionality. So if we look at the additive manufacturing or machining extensions, as well as nesting extensions, just to name some of them, these will unlock extra functionality within the software, as far as being able to actually create nests, create nesting reports from a machining side, extra toolpaths, extra sort of surface probing functionality, toolpath editing functionality, where some of the extensions allow you unlimited access, like the generative design and simulation. Typically those cloud services require tokens to use. So generative design, whenever you want to create a study for generative design, you're required to spend tokens for that study to solve, where if you had the extension, you would be able to solve as many as you want without having to worry about the tokens required. And the same goes for simulation as well. Each cloud-based simulation would require a certain amount of tokens. And if you have the extension, you would be able to simulate without the use of those tokens. So what we're looking at specifically today is the part design extension. So this extension will unlock extra design features, product design extension. And these will unlock extra features within Inventor to allow for the creation of more complex components, quicker creation of more complex components. So as I said, we're looking at the product design extension, and I typically see this extension being broken down into two different sides of that extension. We have quite a lot of focus on plastic parts within the extension, but then there are a couple of other tools that are unlocked which help with sort of other workflows within the design environment. So if you're a person who's designing plastic parts and you have, and the plastic parts are typically quite complex, in general, plastic parts can be quite complex. They have a specific functionality that they have to achieve, whether it's a cover on a piece of electronics that has to clip together. We've got that functionality of the clips on the two halves. If it's a cover for a power tool, the functionality that we have to build in there is that it has to be strong, it has to hold components within it, and we have to be able to screw the two halves together to be able to unscrew it and perform maintenance on that tool. So plastic parts typically are quite complex. They have to have functionality designed into them. And what we'll see with the extension here is that we are able to sort of automate that process and also create design rules that will help with the process of designing that component. And at the end of it, we would be able to run checks that would check the part design for specific issues related to the part itself and in the plastic environment. Let's say we're looking at molding, then we can look at that part with respect to molding and see, are there areas that are too thick, are there areas that have knife edges, are there areas that don't adhere to those design rules that were specified. Then on the other hand, part of the extensions, we see that we are able to speed up the design process. Now, kind of linked to those rules, we get the ability to have presets as well as having certain commands pull information from those rules that are set up, and that helps speed up the design process and reduce the amount of input from the designer. We can also use the convert option to convert mesh data into T-spline data. So if you're doing reverse engineering, we would be able to convert data in that reverse engineering environment using the organic conversion option in the extension. And then lastly, you may want to be able to create complex geometry quickly, and we'll see with the tools available to us that that helps us create that geometry. So moving on to the first section that we will have a look at, and that is the plastic rules. For those that have worked with sheet metal, it's very similar to sheet metal, where you would set up a set of rules similar to your sheet metal. So if I had to draw comparisons from a sheet metal side, you set your sheet metal thickness, you set your bend radius, where here with your plastic rules, you would set up your plastic material, so the actual material itself. You would set up the thickness for that material that you would want to adhere to throughout your design process. And we will see a couple of options on the right-hand side there with regards to the range of thickness that is allowable, that we will be able to check for at a later stage and have warnings if it's outside of that range. We have draft angle, so depending on whether or not we're working with a harder plastic or a softer plastic, we can adjust the draft angle accordingly. And we've got those various options available under the rules. Now, why have these rules? And we'll talk about presets on the next slide. This allows you to ensure design consistency. When creating the plastic rule, you're saying with this plastic, we want to have a specific draft angle or a specific minimum draft angle as well. And so your designers can assign that rule and then know that those values are being carried across through into the design. So having these rules, and then later on we'll see presets, allows for that design consistency. It also allows to automate designs. We'll see in the demo that I'm going to show you that when we create a component and then shell that out, the shell thickness for the wall automatically pulls the thickness value from the rule. So we're shelling to that predefined thickness. When adding a draft, the draft is pulled from the rule so that we don't have to go and find that draft angle and input that draft angle in the draft box. And at the end of the day, it allows for us to check for manufacturability. We can check against these rules using the tools that we'll see later on of how to check and see if that component is manufacturable. Now, the rules themselves, you are able to adjust and create the rules in the document as needed. We can see on the right-hand side here, we have the plastic rules, the list of the standard library rules, and then in this design, currently with that picture there, there's no rule assigned, but we see the smaller insert there where it says main body 1, plastic rule polypropylene. That component has that polypropylene rule assigned to it. And you would be able to go into that rule and update anything in that rule as needed per component or within the library and update the library rules. So the rules can be adjusted and created as needed, and they can then be assigned to each of the components in the design. Now, with presets, when using presets, we can set up presets for each supported command. So here we see that on the right-hand side, we have the boss, snap, fit, and rest commands. And each of those commands have these presets. Presets are available in various commands within the software, and you would see that preset bar at the top. Then when you are creating your feature, there would be the Fusion 360 default preset, but you can also adjust those presets. So we can see there we've got the used per feature. So the presets are set per feature. Create a boss feature, it has a preset. And then we can see that we have essentially default presets. So the Fusion 360 default. And when you go away from those defaults and you adjust and you set your own values, that then becomes what's called a preset feature. And that can also be saved as a user preset. So the nice thing is you can create the presets required for, let's say, a boss that's being added into a component, and you can then save that as a user preset. If you have multiple styles or types of bosses that you generate, let's say the geometry changes from one to the other, you can then store multiple presets to easily be able to switch between presets and have the geometry update according to the preset. So this leads us into our first demo. So I'm going to go ahead here to Fusion, and just to show you within this component that I have here, we have, if I go up to the Utilities tab, Plastics tab, if we go into the Plastics tab, we have the setup for the Assign Plastic Rules and Manage Plastic Rules. So we'll see that this document already has a plastic rule assigned. It's ABS 1mm. But if we go to the Manage Rules, we can see that previously there was also a nylon rule assigned to the document. So we have those two different rules. There are various rules in the library as well, and you can edit or even create new rules based on the existing rules. We'll see here that I have a nylon PA6 rule, and its thickness is set to 2.5. And if we have a look at the draft angle, that draft angle is set to 3. And the ABS, we have a thickness of 1 with a draft angle of 2. And so what this allows us to do is it allows us to stick to different design criteria for the different materials, but also allows you to quickly change by adjusting the rule that's assigned to the other, to a different rule. So here I'm going from ABS 1mm to nylon PA6 2.5mm, and if we look at the design in the background, we will see once I've selected that rule and hit OK, the design is updated with that new thickness from the rule. So that's part of setting up the rules, is being able to have that information carried through. And the way this is done, if we go have a look at the timeline, if I edit the shell feature automatically pulls the inside thickness from the rule. So that T value there is a parameter value for thickness from the rule that was set. So we can currently see that the thickness here, if I hold my cursor over that, the value is 2.5. The same also applies for the web that was inserted in the design. We can see that the web thickness is set to T, as well as the draft angle and fillet radius for the feature that is pulled from the rule. So draft angle pulled from the rule, and the fillet radius, we've got the thickness multiplied by 0.5. And that fillet is automatically added wherever that web blends with the original part. Now, from a presets perspective, we're able to go into a command. We're getting a little bit of a sneak peek here at the boss command, and you can drop down and you can choose last used values, Fusion 360 default, or the values that are currently set for this feature. However, let me go have a look. So one of these features, I do have a predefined preset. So here we see my draft. That is my preset that I created. So if we have a look at the current values, we've got the thickness, we've got the fillet radius is t times 0.5. If I change that to my draft, we don't have any change in the update there. But if I go to Fusion 360 defaults, we'll see that the fillet radius is reduced down to t times 0.25, so a quarter of the thickness. And so we can see in the preview, as that preset is changed, the fillet value is updating. So that allows you to change between presets as well as adjust or change between materials and have the model update according to those changes. So a nice quick short little demo there showing the plastic rules as well as the presets. We'll head back into the presentation and we'll have a look at the plastic design tools that the extension unlocks for you. So what we'll see in the plastic design tools are a couple of plastic specific geometries that can be applied to your components. So here we see the boss command. So we're looking here specifically at adding bosses within a design. And the boss command allows you to pick center points that would be the center axis for your boss. And it then generates the actual 3D geometry from that selected location. And this allows you to create that geometry very quickly with minimal input. Once again, thinking about your design rules or plastic rules and your presets, this can be pre-configured so that your designer just needs to select the presets from the drop-down. So we'll see that we can generate that boss geometry quickly. It is preset and rule driven, but it is also customizable, and you also have the ability to add fasteners. We'll be doing a demo. We can just have a look at the feature dialog box. What we see here is less than half of the information that you are able to put in that feature. So we have the ability to quickly generate bosses within a design, but we also have the ability to quickly generate snap fits within a design as well. So if you have two mating components that need to snap together, you're able to quickly generate that snap without having to manually draw out all of the sketches and the extrusions to generate that. So once again, snap fits allows you to generate the geometry quickly. It is also preset driven. It is also rule driven. Once again, it is customizable. You can change or set the type of hook and loop that is used. We can see this in the dialog box at the top. We've got options with regards to the type. So we've got 3 various types there. And we can also adjust the dimensions for both sides of the connection as well. Moving on to geometric pattern. This allows you to create more flexible patterns within Fusion 360. So we are not stuck to using just a standard rectangular or circular pattern. The nice thing with this is that you don't have to have any geometry to start with that you need to pattern. You can basically pick a face, and there are standard shapes that can be used on that face. So if we have a look on the far right-hand side, we have 4 options there where we see different geometric patterns using a sphere to cut out a dimple in those components. And I think the bottom one here looks like it's a cylinder. But we can choose those standard shapes to pattern across a selected surface. But you can also customize the shape. So on the side of this camera that we see here, there's the Autodesk A, and that was created as a solid body in the part, which is then patterned using this tool. So you can select that as your source, and that pattern is then brought through onto the selected face. And this works as a way to distribute that pattern on the selected face. So we can see all of these, top face of the button has been selected and the pattern is distributed across. Now you can use, like I said, the standard shapes or custom shapes, but you can also change the size. So you can vary the size and the spread of the object in the pattern. And there's also the distribution type. So just to talk a bit more about distribution type, you can see here on the right hand side, there are 3 different distributions being used here. The tops, they are forming hexagons. In the middle, it's a radial distribution from the center out, and below that we have a circular distribution. The 4th one is also a hexagonal distribution, same as the top one. Then we get to the design advice tool. This comes close to the end of the design process if you want to check for manufacturability of the component. With plastic parts, the thickness is a very important part of the molding process. We want to make sure that the thickness is as uniform as possible throughout the component. So we can check for issues such as component thickness. So that's the top left image there that's shaded in blue and green. We can see the thickness change, and we can highlight some potential issues where we see the green stripes on the outside of the part. That's where we are potentially going outside of our required thickness. We can maybe see some sink marks there in that component. The bottom would show us, so the bottom image here is showing us undercuts. And so we can see that we have that block that is overhanging, and we have the undercut below that. So this will highlight areas where you may need to have a slide or an insert within the mold to help with the molding process. And then on the top right, we have the draft shown. So those faces that are highlighted in red in this case do not meet the required draft angle for the plastic that was set. Those faces in this case have a 0 draft angle. And then lastly, knife edge. We don't have any knife edge images shown here, but this would highlight any sharp edges that could potentially break off in the mold when the part is demolded. So potentially at the top of these ribs, if they came to a sharp point, that would be highlighted as a knife edge. So with that being said, we can move into Fusion to have a look at a demo for those tools. I'm going to start with the camera. Let's have a look at just get that component back here. Let's get so we have a look at the boss first. So if we look inside of this camera, we have these bosses that are molded into the housing. And I'm going to go ahead here to the end of the timeline. Where we see the various features. So here is the boss feature. If I select that, we can see the 4 bosses are highlighted. I'll double click on that to edit that boss feature. We can have a look at what we have got going on in the boss feature. So we'll see right at the top, we've got the options to show the visibility of the components that are involved. So we can change them to transparent. We'll see the top, the 2 halves of the 2 components that are connected with these bosses, they are set to transparent so we can see the boss. And I've also got this set to section the boss so we can see the cross section of the boss being created. So we have the orange and the blue describing the 2 halves of the boss. And if we go through, we can see that for the boss, we can add fasteners. So in this case, we have screws holding these 2 plastic components together. And so we can choose the type of screw, the shape of the head, the drive used to drive that screw into its thread, the thread information and screw length and diameter can be adjusted. And then if we scroll down past the fastener information, we can have a look at the specific sides of the boss. So if we look at side 1 here, that is the right hand side of this camera, and we can see the material assigned to that side, the rule, polypropylene, 3mm, and we can adjust the boss itself. So if we have a look here in the center, we can go ahead and change the step type from in to out, and that will update the geometry at that point where they meet. And then if we go have a look at the advanced options, we are then able to set all of the geometries for the boss. So we see there's quite a long list here of all the different geometries. And bearing in mind, once again, when you go and you change all of this information and update this information, you are able to save this by clicking on the new preset icon to save this as a preset boss design. So the next time you need to add a boss into a component, you can click the drop down and select your presets. You'll see here as well, there are various parameters being used. So HD for the head diameter of the hardware being used, plus a bit of clearance, thread diameter. We've got some various other values here, A1 and T1 being used to update the geometry. If you hover over that, that will give you a description of what is required there for that input. And we can see A1 is the counterbore diameter plus the thickness, T1, to give us that total value. And you can go and customize these as required. And the same goes for the side 2. We can expand side 2 out. We can set the type and the hole depth type, as well as the advanced options for that. So we can adjust the values as required there as well. Once that is complete, we can also choose to add ribs to the boss as well. So there's a ribs tab, and we can adjust if we want ribs on side 1 or side 2 or both. And we'll see here when I select that, it is then generating the rib geometry. My laptop just needs a second to catch up. And there we can see the rib geometry being displayed around the boss. And you can adjust how many ribs you need, the angle covered by those ribs. If you need to rotate the ribs, you can rotate that round. So let's have a look. We might have some interference in the design here. So let's rotate the ribs by 45 degrees. And we'll see the orientation of those ribs rotates accordingly. So there they've rotated 45 degrees. And same as with the boss itself, you can go through the list, you can update the values as needed. And then when executing that, that geometry will be created. So quite easily here, I can add those ribs onto the bosses. Just give that a second to calculate out. So you can see there on the bottom right, my Fusion working away, compute finished, and we now have that added in. So let me just go ahead and quickly hide the central body and the left side, and we can now see that right hand side with those ribs molded in with the boss. So that's having a look at the ribs. We also have the snap fit option. So I'm going to go ahead here, double click on the snap fit. We need to set the central body visibility back on for this one. So we can see our two components that the snap fit will act on are highlighted, they're transparent and blue. And if I rotate this view around, we'll be able to see the two snaps that will be created to be able to snap the cover on before using the screws and the bosses to connect the two together. So here in this case, we can see that the snaps are both essentially pointing to the left. I'm going to go ahead here and change the rotation angle for these to 90 degrees. We'll see the snaps will rotate to 90. So that will be a bit more functional for this part. And because we are editing the snaps, we cannot change the type. You'll see that we have basically a hook and a groove set up for this one. Sorry, this is a hook and a parallel hook and groove that we have set up. So it is creating the hook geometry on the one component, and then it is removing material out of the second component to create that groove. And we have the other options here of perpendicular hook and groove, as well as hook and loop. And as we saw with the boss feature, if we scroll down, we can see that we have the ability to adjust the hook geometry. So we have those various parameters there and values that we can adjust, as well as then the groove geometry as well. So we can go in quite easily, adjust the values or set according to a preset. So we have that preset up at the top here again. So I'll hit OK there. That will then generate or rotate those hooks and the resulting grooves, and that will then update in our model. So if I go ahead here now and hide the outer body geometry, we can see the hooks there on the inner body. And if we go around the other way, rotate this, we can see the grooves there within that outer shell for the hooks to hook into. And then we'll move on to the geometric patterns. I do need to switch on a couple of components here. Let me have a look here. Go back to the right side. I'm going to switch on all of these components, and then we can see, as we saw in the PowerPoint, we've got the various buttons with the various patterns on, and we can go ahead and edit one of these patterns. This pattern in particular was created using a standard object type, so we can see that it is patterning cylinders across the selected face. So that top face was selected, and those cylinders are being patterned across that face. We have the size limit set between 0.5 millimeter and 2.5 millimeters, and there is a spread that adjusts the range in which the sizes are going to be adjusted between. So do we want more sizes towards the high end of that range or towards the low end of that range? You can adjust this between -1 and +1. I'll leave that centered in the range. We also have the distribution type. So this is what's going to create the resulting shape that we see. So if we go with rectangular, that would be your standard rectangular pattern. Triangular, you would get a set of, essentially a set of triangles. You can see that we are creating groups of triangles here. Hexagonal creates groups of hexagons.